Okay, velocity, just looking at the rest of the booklet, velocity is the rate of change of displacement with respect to time. We spoke about that before. So it's the gradient of the displacement versus time graph, or it's dx dt. So acceleration, so you'll be familiar with the acceleration, for example, when you're driving a car. So if you are speeding up, that means your velocity is increasing, then your acceleration would be positive. Okay? And if your velocity of your particle is decreasing, now this is just a very simplified version. There is actually a little bit more to this because it depends on the direction in which you're traveling, okay? So if the velocity of the particle is increasing, then your acceleration is positive if you compare it to the direction of the velocity, okay? Now, if the velocity of the particle is decreasing, in other words, if you're slowing down, then the acceleration will be negative because the acceleration is the gradient of the velocity versus time graph. So you know if you're accelerating, it's like you're going faster, okay? So the velocity is increasing. You know that if you're slowing down, it's like you're decelerating, okay? So acceleration is negative. As I said before, in Year 12, you'll do more on this, where this really will only be negative if you're comparing it to the direction of the velocity, okay? Now, for example, if you're on the freeway or on any road and you're just traveling at the same speed, so you're moving with constant velocity, then you're not accelerating, so you're not going faster, or you're not slowing down, so we actually call slowing down decelerating. So if you're just staying at a constant velocity, so if your velocity is not changing, same speed, then your acceleration will be 0 because the velocity is not changing. Okay, now, acceleration, so just like velocity is the gradient of the displacement versus time graph, so if you've got an x versus t graph, its gradient is called the velocity. But then if we can also draw a velocity versus time graph, and that might look different, and it will look different. So the gradient of that, velocity versus time graph, is the acceleration. So the gradient of the displacement versus time graph is the velocity, and the gradient of the velocity versus time graph is the acceleration, okay? So all you've got to know, velocity is dx dt, and then one step further, the acceleration is how your velocity changes. So it's dv dt, okay? So with these questions here, there's no graphing, it's just you might start with, or you will start with the displacement, and you'll have to work out the velocity and the acceleration. And then there'll be some other questions that you'll answer as well. Now, the first question is, the displacement, x meters from the origin at time t seconds of a particle travelling in a straight line is given by this, x equals t cubed minus 9t. And the first question says that show that the particle is initially at the origin. Now, initially means when time is 0. And it's asking us to show where the particle is at, so we want its position or its displacement. So when when t is 0, we have to find x. So we just substitute t is 0 into this equation. So we get x equals 0 cubed minus 9 times 0, which is just 0. So initially, so therefore when t is 0, x is 0. So it's at the origin, okay? Now, the next question says to find the velocity at time t seconds. So we just want to find the equation for velocity. Now, we know that x equals t cubed minus 9t. We know that velocity is dx dt. So it's the derivative of this. So I differentiate this. Remember, I bring the 3 to the front, write down the t, and drop the power by 1. Minus, now if I differentiate 9t, I just get 9. So instead of being y and x, y as a function of x, which is what you're used to seeing, we're looking at x as a function of t. So to do dx dt is just differentiating. So bring the 3 down, write the t out, drop the power by 1. And here we drop the power of the t. So we get -9. So this is now my velocity formula. So now I can calculate the velocity at any time. So they're asking us to calculate the velocity when t is 2. So I just substitute t is 2 into this equation. I get 3 times 2 squared minus 9. So 3 times 4 is 12 minus 9. That would be 3. Now we just look at the units, actually. And x is in meters and t is in seconds. So the units of velocity will be meters per second because it's the change in x over the change in time. And you just think of velocity also as your normal speed units, okay? Now, the next question says, find the time when the particle is stationary. So if the particle is stationary, it means it's not moving. That's velocity is 0. So you really want to find the time when velocity is 0. Now, we do have a velocity equation. It's 3t squared minus 9. So I've got velocity is 3t squared minus 9. So I want to see when that is 0. So I go 3t squared minus 9 is 0, and I need to solve that. I can divide everything by 3, and I get t squared minus 3 is 0 if I divide through by 3. Or I could have just factorized as well, okay? So I could have gone 3 bracket 3, taken out 3 as a common factor, t squared minus 3 is 0. So I end up with t squared minus 3 is 0, so t squared is 3. So t equals plus or minus the square root of 3. Now time is in seconds, but we cannot have negative time, so there is no negative time, so the time is square root of 3 seconds, as time has to be positive. So square root of 3 seconds, that's approximately 1.7 seconds if you just do that on your calculator. Now the next question is to find the acceleration at time t seconds. Now we know that acceleration is dv dt if you look further up on your sheet. So I know that v is 3t squared minus 9. So I've got v equals 3t squared minus 9 if I look up here. So acceleration is dv dt, so I differentiate this. So that'll be 3 times 2t, and when I differentiate 9, I get a constant, so acceleration is 6t. That's my equation for acceleration, okay? So now find the acceleration where time is 2, so acceleration is 6 times 2, which is 12. Now we had meters per second for velocity, so it will be meters per second or meters per second squared. Okay? Yeah. Okay, question 2. A particle is moving such that its displacement x is given by x equals 2t squared minus 8t plus 3. Now if you look at that, you'll recognize that as a concave up parabola. Okay? And I've actually got it sketched further down on the page. Okay? Now the first question is to find its initial displacement. So that's asking me to find x, which is displacement, when t is 0. So I just substitute t is 0 into this equation. And I've got x equals 2 times 0 squared minus 8 times 0 plus 3. So it's 0 minus 0 plus 3, so it's 3 meters. So that's the initial displacement. And the next question is to find the initial velocity. Now we know that velocity is the rate of change of the displacement, so it's dx dt. So if I differentiate this, I get 2 times 2t. And if I differentiate minus 8t, I get minus 8. So my velocity equation is 4t minus 8. But we want the initial velocity. So first you have to find the equation for velocity. Then you substitute when t is 0. So when t is 0, the velocity is 4 times 0 minus 8, which is negative 8. Let's look at our units, meters for x and seconds. So it's meters per second. Now that doesn't mean that it's traveling at a negative speed. You cannot travel at a negative speed. So it's traveling, how do we interpret that result? At 8 meters per second to the left, okay? So let's see what we've got so far. Initial displacement, so when time is 0, its position is 3 meters. So x is 3 meters, that means it's to the right of the origin. So we're starting 3 meters to the right. And then we're traveling at a speed of 8 meters per second to the left. Okay? Now, so we start on the right. If we look down here, I've got the diagram here. So we start at time 0, x is 3. And then I am traveling towards the left because look, I'm ending up here at x is 2, x is 1, x is 0, x is -1, x is -2 for these particular times. Now the next question is to find when the particle will be at rest. Now at rest means that the velocity is 0. It's not moving. So that's my velocity equation. So I just put this equal to 0. So 4t minus 8 is 0. And if I solve that, I get that t equals 2 seconds. So it's 8 divided by 4, which is at 2 seconds. Now, we've got our graph of x versus t here. And look, we're traveling to the left. Negative velocity, gradient's negative. And at 2 seconds, I see here that the velocity is 0. So the gradient of my curve is 0. Here, the gradient of my curve is negative, so I'm traveling to the left. Here, the gradient of my curve is positive, so I'm traveling to the right. And we should see that now with our questions, okay? Now, it's asking when is the particle at rest, and we've set at time 2 seconds, and it says what is the position of the particle at this time. So they're asking us for x. So when the time is 2 seconds, they want us to find the position, which is x. So we have to go back to the original equation, which is x is 2t squared minus 8t plus 3. And I substitute t's 2 into that. I get x is 2 times 2 squared minus 8 times 2 plus 3. And that's 2 times 4 is 8 minus 8 times 2 is 16 plus 3. 8 minus 16 is -8 plus 3 is -5. So what is its position? Its displacement is -5, so it's 5 meters, and the negative means that you're to the left of the origin. Now let's have a look at our graph and see where we are at time 2 seconds. So at time 2 seconds, we're at the position of -5, which means that we're 5 meters to the left of the origin, okay? Then it says to find the velocity at 3 seconds. So I've got my velocity equation here. It's 4t minus 8. So I just, I've got v equals 4t minus 8, and I substitute t is 3. So it's 4 times 3 minus 8. So that's 12 minus 8. That's 4 meters per second. Now that means that you're traveling, because it's a positive answer, traveling at 4 meters per second to the right, because it's positive velocity. So let's have a look at 3 seconds here. The gradient of our curve is positive. If I actually try to work out that gradient, it would be 4, okay? Okay, now, okay, good. Now the next question says, show that acceleration is constant and find its value. So we've got the equation for velocity. It's v is 4t minus 8. And we have to find the acceleration. Now we know that acceleration is dv dt. And if I work out the velocity of this graph, sorry, not the velocity, if I work out the derivative, if I differentiate this, so if I differentiate 4t, I get 4. And the units would be meters per second squared, which is a constant because there's no t next to it, so its value never changes, okay? Now, we need to describe the motion of the particle, and we can see what happens here. So the particle starts at x equals 3. Particle starts at 3 meters to the right of the origin. It then travels to the left because it's negative velocity. It travels to the left for 2 seconds until it is 5 meters to the left of the origin, where it stops. It then turns around. Oh, you can just, don't need to say it turns around. It then travels back to the right because the velocity is positive for another 2 seconds, because they just want the motion of the particle in the first 4 seconds where it is back at its starting position. Because at time is 4, it's back at x is positive 3. So where it's back at its starting position of 3 meters to the right of the origin. Okay, so that's the motion of the particle. If I'm just going to ask another little question. How far did it travel? What is its distance traveled? So it has started 3 meters to the right of the origin, then traveled to 5 meters to the left of the origin, and ended it back at 3 meters to the right of the origin. So if I've got my 3 and my -5 for 5 meters to the left, so it starts here, it goes there, stops, and comes back around to there. So it's traveled 8 units to the left and 8 units to the right. So the distance traveled is 8 plus 8, 16 meters. So always distance traveled is positive. Okay, but its displacement, it started at x is 3 and it finished at x is 3. So it's got a 0 overall displacement, but its distance traveled is 8 meters to the left and then 8 meters back to the right, which gives us a total of 16 meters. Okay, now for the last question, question 3, the displacement x in centimeters after time t seconds of a particle moving in a straight line is given by this equation. Now if you look at this, it's a concave down parabola and it's drawn here. So if I just look at this graph, look at the gradient. So this is an x versus time graph, displacement versus time. It's graphing this, 2 minus t squared. So the gradient of the graph is the velocity. So my gradient's positive, so I've got positive velocity. And my gradient here is 0, so I've got 0 velocity, so I've stopped. I must stop here. And then gradient's negative, I've got negative velocity. And where it's quite negative, quite steep, it's going faster. So it's faster here, and then it's slowing down, and then it stops, and then it turns around and travels towards the left. Okay? So negative velocity traveling to the left, positive velocity traveling to the right. Okay, let's have a look. So find the initial displacement. Initial means when time is 0. Displacement, you want to find x. So x is 2 minus time is 0 minus 0 squared. So you're starting at 2. So initial displacement, you're at 2 meters to the right of the origin. So it's important to say, to interpret your answer. Okay. And then it asks, find when the particle will be at the origin again. So you're putting, if the particle is at the origin, x is 0. So I substitute x is 0 into my equation here. Now to be able to factorize that, let's take everything over to the left. So I've got t squared plus t minus 2 is 0. And I factorize that, and I get t plus 2, t minus 1 is 0. And solving that, I get t is -2 or t is 1. But time has to be greater than 0. You can't have negative time. So therefore t is 1 second. So find when the particle will be at the origin. So now just got to be careful here. Sorry, I need to say something about this. This is time. All of this doesn't exist, sorry. So you're not going to get it stopping because that's all negative time. So that actually is not relevant to your graph. So remember the first question was find the initial displacement. So when time was 0, find where you are. So here's time is 0. Yes, you are at 2 meters to the right of the origin. And then it asked when will the particle be at the origin again. And we said at time 1 second. So at 1 second of time, yes, you're back at x is 0. Okay, so we've just looked at these two. So if you start at 2 meters to the right of the origin, that's where we started, and then after 1 second you're back at the origin, then your displacement after 2 seconds will be, after 1 second you ended up back at the origin. We want our displacement at 2 seconds. If you look at the graph, it says -4, so you're at 4 meters to the left, but we can substitute, into our equation. So find the displacement after 2 seconds. So you use your x equation and you sub time is 2. So displacement is your x position after 2 seconds. So sub t is 2 into the x equation. You get 2 minus 2 minus 2 squared. Now 2 minus 2 is 0, minus 2 squared is minus 4. So therefore you are 4 meters to the left of the origin. And you can see that here in your graph. So 4 meters to the left of the origin at 2 seconds. At 2 seconds, you're at -4, which means 4 meters to the left of the origin. And it says, when does the particle come to rest? Now, we're saying it happens here, but this time doesn't exist. Now, let's see what happens here. So we know that x, I'm just writing the equation down, is 2 minus t squared. So I know that velocity is dx dt. Now I differentiate this. If I differentiate 2, I get 0. If I differentiate -t, that's differentiating -1t, I get -1. And if I differentiate -t squared, I get -2t. Now when does it come to rest? That's when v is 0. So I put this equal to 0. -1 minus 2t is 0. So I get that 2t is -1, or t is -1/2 a second. Now, you cannot have negative time, so therefore it's never at rest, because t must be positive. So never at rest because t is positive. So we did see we've got our gradient was 0 here, but this is actually at negative time. So this bit of the graph doesn't apply. So that formula that we've got here for the displacement only applies for time greater than 0. Okay? Okay, so if this maximum point up here was over this side of the graph, it would be okay, but it's on the negative time side of the graph, so it'll never be at rest. Okay? And the other question was to find the velocity after 2 seconds. Now I know that velocity is -1 minus 2t. And then I sub time is 2. So I get velocity is -1 minus 2 times 2. So it's -1 minus 4, which is -5 meters per second. Now it doesn't mean that I'm traveling at negative speed. It means I'm traveling at 5 meters per second to the left. Remember that negative velocity means that you're traveling to the left. And we can see here the gradient of our curve is negative, so we are traveling to the left. And we've actually been traveling to the left from the very beginning here. From time 0, the gradient of this curve is negative for the whole curve. Okay, this bit of the curve doesn't really exist because it's negative time. Okay, and that's the end of that.